All right, number 8, writing equations. So here we have 4 functions that have been transformed, and we need to write equations for them. I am going to start by identifying the parent function and then go from there. So this first guy, our upside down, is our upside down b. So the parent function there is absolute value. So absolute value usually is centered at 0, 0 and has a slope of +1 on the right branch and -1 on the left branch. This has been moved, the vertex has been moved to 1, 2, 3, -3, -3, 4. And it's been reflected since it's now opening down. But our slopes are still good. So we have 3 transformations happening here to absolute value of x. It's reflected over the x-axis. It's moved left 3 and up 4. So our equation, to get that reflection, we need a negative on the outside of our function. Left, we're going to do x plus 3 on the inside there of our, usually we'd have parentheses, but we have the absolute value sign that acts as parentheses there for us. And then up 4 is plus 4. So that's your first graph there. I think it's really helpful to sketch in kind of the parent graph for the first couple ordered pairs like I did there. And that's what I'm going to do with this next one. Here we have our parent function for this guy. Our general shape is square root of x. Square root of x usually has its first little point at 0, 0, and then up 1 over 1, over 4, up 2. Square root of 4 is 2. Square root of 9 is 3. So there are your ordered pairs that you have memorized for x, or square root of x. So let's see what's happened to square root of x here. I see that my first point, your kind of starting point here for your transform function, is left 1, down 2. So since that's left 1, down 2, since that's -1, 2, it's left 1, down 2. The other thing we have happening here is this looks taller than normal. So this is going to be a vertical stretch. And you can see the difference here. Usually, I drew the parent function. Usually we go over 1, up 1. Here we're going over 1, up 3. Usually we go over 4, up 2. Let's see what happens when we go over 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So this one was up 3. This one is up 6 when it's usually 2. So there, that is a vertical stretch by a factor of 3. So to put that in an equation, vertical stretch goes on the outside, so the 3 is going to go on the outside. Under the radical, we're going to deal with that left, so x plus 1 is going to get the left 1. And then down 2, the -2 is going to be on the outside of the square root. Okay, a couple more. This is x cubed. Use those flashcards if you got them, if you need to. Usually x cubed starts at, it has a center point at 0, 0, up 1, over 1, over 2, up 8 is usually that next point. So that's what our normal graph looks like, our parent function. Here, that center point has been moved right 2, up 1. And then instead of over 1, up 1, we have over 1, up 2. So that is going to be a vertical stretch by 2. Now, usually when you could write a vertical stretch or a horizontal shrink, you can kind of do either one, but I like to do the easiest. The easiest situation is to deal with the vertical stretch. So 2 on the outside for our vertical stretch. Rate 2, we're going to do x minus 2 in the parentheses, and we need cubed on the outside of that. And then up 1 is plus 1. Last one is our favorite little parabola. Everybody loves x. A lot of transformations going on here. X squared usually looks like this. So we've got a reflection over the x-axis to turn it upside down. It's been moved up 9 units. Our vertex is up there at 0.9. And it looks like we have some kind of vertical shrink, horizontal shrink, stretch kind of situation. So let's look at our relationship. So here it looks like over 1/2 down 1. Over 1, 1, 2, 3, 4, down 4. So usually our relationship is over 1, up 1, over 2, up 4. This is over 1 and down 4. So it looks like our x values our horizontal distances have been shrunk in half. The horizontal shrink by 1/2. Okay, so to write our equation, for that reflect over x, we want a negative on the outside. Our parent function is x squared. Move that x if I can. It didn't leave room for my shrink. So when we're dealing with a horizontal shrink or stretch, we want to flip that number and put it in front of our x in the parentheses. So if we started out with a 1/2, we take the reciprocal, so we're going to do 2x there. And then down 9 minus 9. Or I'm sorry, up 9 plus 9 on the outside. Lovely. All right, so there are 4 examples of writing equations. You need to be able to do that for any parent function and for any transformation. Really knowing that original pattern, and even if it's just like for 3 of the 4, I only plotted 3 points and was able to come up with the new function. So you don't have to be able to plot everything, but knowing the basic shape is definitely